I was curious, so I went on our YouTube channel to see what was going on. We're recording this and putting it on YouTube, and I was pleasantly surprised to find that we have 12 other people joining us, which I thought, well, who's going to pay any attention to that? But apparently there are. So, and the mic is picking things up. Are you looking for something, Deb?
I was just making sure that the lights were okay for the screen.
Can you guys see all right? Mm-hmm. You don't take, if you want to, you can probably take them down some more, Deb. It's up to you. The mic does a pretty good job of picking up any questions or anything that you ask. So if you do, just try to enunciate and be as succinct as possible. And we'll continue to share it with anyone who wants to. So,
I told my relatives down in Arkansas, in Louisiana, I gave them the links.
Oh, good.
So they said they're going to be looking at it.
Well, that's good. Well, Jerry, we either have 12 people doing it or we have one guy watching it 12 times. I don't know which it is.
That's the way YouTube works.
Yeah.
So would it be through First Southern Baptist, you get on YouTube and go to First Southern Baptist and then track it down?
I'll send you the link. There's a link for it. Yeah.
Camera on now.
It's on, yep. Okay, well, now that we've answered everybody's questions, we're out of time, so that was... So let's look at this second part of creation versus evolution. And remember last week, we discussed the idea that creation is a scientifically acceptable explanation for the origin of the universe. In this lesson, we're going to look at the alleged factuality of evolution, as well as some of the evidence that documents why the concept of creation is much more consistent with true science than the idea of organic evolution. Organic revolution means, never mind, I was going to make up something. But, you'll recall that we're using although I brought another resource with me tonight, but we're using two primary resources. The first is the booklet that we put together out of Apologetics Press we're calling it Apologetics 101. The second is a book by Norman Geisler and Frank Turek called I Don't Have Enough Faith to Be an Atheist. And throughout the book, they continue to make the case that it takes more faith to believe or to put your faith in all parts of creation, of evolution, than it does creation. That's exactly what we're going to talk about tonight, is what about the facts of evolution as a science? So I want to deal with that a little bit. When we talk about the origin of the universe and those things in it, we can't speak as eyewitnesses, obviously, or first-hand observers, since none of us were present. Although some of the kids next door would probably think that most of us were present at the time, none of us were there. So any scientific discussion then must be based on certain assumptions and hypotheses or theories put in place after the fact. I want to talk a little bit about assumptions, hypotheses, and theories here in just a second. Even in the face of that, though, it's important to note that evolutionists continue, in my estimation, and what's amazing to me about this, and we're going to look at that slide from last week as well. What amazes me about this is evolutionists who claim to be scientists, appear to fly in the face of fact with not much regard for fact itself. And I'll tell you what I mean by that in here in just a minute. But first, let's look at the difference between assumptions, hypotheses, and theories, and law. And we've done a little of this before in some of our others, but this is going to be a slightly different slide that I think is going to help in terms of, now I hope everybody's going to be able to see this. Can everybody see that? The print is a little small, probably for if you're sitting too far back. Dale, can you read any of that?
Yes.
Okay. What this is kind of if you think about it, it's kind of a decision tree. And it's the difference between law, theory, and hypothesis. So look down at the very bottom, and you'll see in black, law, hypotheses, and theory. And the process goes something like this. The first is, does it tell what happens, or how or why it happens? And then you have kind of a decision matrix. In the how and why and the what, is this explanation backed by evidence, whatever the explanation is we're looking at? If you follow the decision tree down to yes, it is based on a wide set of data under various circumstances. If that answer is yes, then has it been proved through different experiments time and time again? And is it generally acceptable with the scientific community? If the answer to that is yes, then just to confirm, it's not about unicorns, right? In other words, this is real stuff we're talking about. That's all the yes line. Now, what happens if there's no answers to any of this? Is it based on a wide set of data under various circumstances? If the answer is no, you come to kind of the middle line here. Is it testable and falsifiable? In other words, can you test what it is you're trying to do? Can we test evolution? We cannot, right? So then if the answer to that is, no, is it about unicorns? Well, no. Okay, then if it is, yes, stop wasting my time. If it is about unicorns, then keep believing, but that's a hypothesis. I mean, it's not going to be a law, I can tell you that. So the point to all of this is, unless you can, through the scientific method, which we're going to look at here in just a minute, unless you can test and prove and continue to prove over and over again, then it is a hypothesis at best, may rise to the level of theory. I'm questioning whether it even rises to the level of theory. Deb, did you find the quote you were looking for in the book you had today? There's another resource which we'll bring in next week that talks about the reality is, while it's called the theory of evolution, it really doesn't even rise to the level of theory. It rises more to the level of a hypothesis. And hypothesis, as you will probably remember from your 7th grade science, is what? It's an educated guess based on tentative assumptions. So an assumption is something taken for granted and represents a legitimate starting point for an investigation. A hypothesis is merely an educated guess, and a theory is a plausible general principle or set of principles that may be used to explain certain phenomena and that is supported by at least some of the facts. That's the difference between the three. Now, here's in the face of that, I want you to note something that Francis Crick and James Walton, the two scientists Watson, who shared the Nobel Peace Prize for the discovery of DNA. Watson wrote this in a book titled The Molecular Biology of the Gene. He stated this: "Today, the theory of evolution is an accepted fact." Well, we just got through proving that it is not an accepted fact. It can't rise to the level of an accepted fact. A few years later, in 1999, in Time magazine, Harvard evolutionist Stephen Gould, who we'll talk about some more, said that, and this is a quote, "Evolution is as well documented as any phenomenon in science, as strongly as the Earth's revolution around the sun, rather than vice versa. In this sense, we can call evolution a fact." So is it a fact? No, it's not a fact. A fact is defined as an actual occurrence or something that has actual existence. With that standard usage definition in mind, consider the following. There are 7, actually I want to go back and look at a slide from last week because I was just flabbergasted, and Dale hit the most interesting point of this slide, I believe. I included it in this week's email for those of you who got the email. Everybody remember this? Religious beliefs among scientists. If I hadn't shared this last week, if I had said, what percentage of scientists do you believe in evolution, what would you have said?
90%.
90%? 90%? That's what we're given, right? I mean, that's what we're told. Well, you're an idiot. 90% of the scientists believe this. Well, here's the reality, and this is from the Pew Research Organization, which I think is probably one of the best in the world. I want you to notice on the top line, all scientists. 33% believe in God. Another 18% don't believe in God, but do believe in a universal spirit or a higher power. All right, what do you want to call it? What do we call it last week? Jim? I don't remember. Jimmy, Mike, whatever we want to call it. What does that mean? There's a higher power. I personally call a higher power God. Well, that's a total of 51% of scientists in this survey, and I forget how many there were, 1,000, or I don't know what the survey was. 51% said that there is a God or there is at least a higher power. Now, I'm not the smartest guy in the world, but I can subtract 51 from 100, and guess what I end up with? 49, right? So what does that mean? That tells me the majority of scientists in the United States believe in either creation, a creator, or something similar to a creator. The real important information, in my estimation, and Dale found this last week as well, is if you look at the age group, go down to the age groups, which is the fourth line down, age 18 to 34. The age group that is becoming the highest, has the highest percentage in belief in a creator or something like a creator, are those who are 18 to 34. 66% of those believe that there is a creator and believe that there is something like a creator. Well then, how is it that these scientists say it's a fact? Well, some of you will probably remember a guy by the name of Joseph Gould. Joseph Goebbels was Hitler's minister of propaganda, and he said this: if you say something often enough with enough force, eventually you can get everybody to believe it. Well, I'm not going to believe it, so I guess they're not saying it with enough force yet. Jerry?
They're doing the same thing with global warming. If you deny global warming, you're some kind of an idiot. They're doing the same thing.
Yeah. Now, let me hit two more pieces to this. There are 7 assumptions. These are non-provable assumptions, and environmental evolutionists will tell you this. There are 7 non-provable assumptions that are used in the theory of evolution. And a guy by the name of Gerald Kirkut boldly listed no less than 7 of these assumptions in his widely distributed book, The Implication of Evolution. The first 2 assumptions he listed were these. 1, spontaneous generation must have occurred. You remember studying about spontaneous generation last week? What did we find? It's called the law of biogenesis. We're going to come back to that and look at it here in just a minute. So the first assumption that an evolutionist has to make in order to make his case is that spontaneous generation must have occurred.
Life from non-life.
Life from non-life. The second is this: spontaneous generation must have occurred only one time. Well, why would that be?
Because they think they see a big relationship between all living organisms.
Well, that's part of it. The biggest part of it is DNA. And we'll come back to that in just a minute. You can't replicate DNA over and over and over again with the same results, because DNA is one common code that's found among all living organisms. You can't replicate that over and over again. It can only occur one time. Now, let's look at, let me find our handy-dandy slide. It's a little kind of elementary, but this would tell you that spontaneous generation will not work. This is called the law of biogenesis. And the law of biogenesis was proven twice, and it's been proven over and over again. By the way, if it's a law, what does that mean? Comports with all the laws of nature, right? That means it's a law. It's not a theory. It's not a hypothesis. It is a proven fact. Well, the first one was Francisco Redi in 1668, and his experiment was, it was pretty simple. All he did was put a piece of meat in a jar, and he left it open, and guess what happened? Wow, we had life from non-life. Then he put a piece of gauze over the jar, and guess what happened? Still life from not life. And then finally, he sealed the jar. Guess what happened? No flies, no maggots, no eggs can enter. That was in 1668. A couple hundred years later, Louis Pasteur did a similar experiment. And you remember the results? What occurred when the atmosphere was unable to get to something that was not living? Nothing occurred, right? That's the law of biogenesis. Life can only come from life. Life cannot come from a non-living object. Yet what does the evolutionists tell us? First of all, spontaneous generation had to occur. Secondly, it had to occur only once. So why is it had to occur only once? All of life is composed of a single genetic code called DNA. And we've looked at DNA before. Because the code is so extremely complicated, and because it's virtually the same throughout all living things, we'll see a little bit more about DNA later tonight, with only minor variations, evolutionists are forced to concede that the events that produced it must have occurred just one time. To suggest that it could have happened more than once, and that it produced exactly the same code each time would be ridiculous. No one would believe such. Although, what are their two assumptions? Two of the 7 assumptions of evolution deal with the first, spontaneous generation, and secondly, spontaneous generation could only have happened once. Now, there are 2 serious problems with this. First, I want you to remember what this is based on. It's based on an assumption. Right? First, something that is based upon an assumption never can be considered a fact. At best, any idea based on an assumption forever remains just that, an assumption. An assumption remains an assumption until what? It's proven. Not only is it proven, it has to be replicated. So that's the first problem with it. The second is this: all scientists know one-time events cannot be studied using the scientific method. We'll look at what the scientific method here is in just a second. But why is it the case? Why is it that one-time events cannot be studied using the scientific method? There are 3 pieces to it. That's one of them. First of all, science uses the 5 senses to study things that are, and these 3 things must be there. Must be universal, must be able to replicate it anywhere, must be dependable, must be able to do it over and over and over again, and the third, must be reproducible. Can any of these things meet any of that criteria? Cannot. So that simply means that a scientist working in Hong Kong can do an experiment exactly like a scientist in New York City. If both use the same methods, both are going to get the same results. Today, tomorrow, next year, or 10 years from now. The results can be repeated over and over and over again. One-time events are neither universal or dependable, and by definition, they cannot be repeated. Even evolutionists have to admit that 2 of the 7 non-provable assumptions, which are spontaneous generation and occurring only once, cannot occur in the field of science. So on one hand, they're saying these are assumptions that we're making that you have to believe in order for evolution to be accurate, and we believe they are. And on the other hand, they're saying you can't prove any of these by the scientific method. Now, what kind of scientist is that? Well, I'll tell you, it's a scientist who has faith in something else. Everyone has faith. We talked about this in our very first session, didn't we? Everyone has faith in something. You either have faith that all mankind came from some kind of a primordial soup, or you believe that intelligent, and I'll even use the term, an intelligent designer, AKA God, did it. Either way, you have to have faith. Now, I want you to listen to what Dr. Kirkwood admitted, the guy who came up with these assumptions. He said this: the attempt to explain all living forms in terms of evolution from a unique source is premature and not satisfactorily supported by present-day evidence. Does this sound like a scientist? The supporting evidence remains to be discovered. In other words, what he's saying is, well, it's there and we're sure it's there, we just don't have evidence for it, but we think there's going to be evidence at some point in the future. You're going to find that that's the exact same thing that Darwin does here in a few minutes. The supporting evidence remains to be discovered. We can, if we like, believe that such evolutionary systems has taken place, but I, for one, do not think that it has been proven beyond all reasonable doubt. That's the guy who came up with the assumptions, the 7 assumptions that led to evolution. Later, when discussing the various aspects of each of the 7 non-provable assumptions, he observed this: the first point that I should like to make is that these 7 assumptions, by their nature, are not capable of experimental verification. If they're not capable of experimental verification and replication, then what do you have to do with them?
You have to throw them out.
You got to get, that's a hypothesis that you haven't been able to prove. And you'll remember for your 7th grade class, if the hypothesis is not provable, what do you have to do? You start over and you change the parameters of your hypotheses until you can prove that hypothesis. If you can't ever get to the point where you can prove it, what do you do? Right? The evidence, and he goes on to say, the evidence that supports it is not sufficiently strong to allow us to consider it anything more than a working hypothesis. He just got through saying that evolution is a hypothesis. Now, the standard, let me finish up with one last piece here. The standard usage definition of a fact is something that is an actual occurrence or something that has actual existence. Can any process be called an actual occurrence when the knowledge of how, when, where, what, and why is missing? It can't. So how can both Gould and Barnack, whatever his name was, how can they say this is a fact? Now, it's not just creationists have made the point as well, but it's not just creationists. An Australian molecular biologist and an evolutionist, by the way, by the name of Michael Denton, addressed this very point in a 1985 book, Evolution, A Theory in Crisis. First of all, let me point out, he is an evolutionist. After admitting that no one ever has documented any evidence for the supposed evolutionary chain of life leading from one type of creature to another, Dr. Denton wrote, "The concept of the continuity of nature has existed in the mind of man, never in the facts of nature." Let me say that again, and if you want to, you can underline it. It's on page 3 of your handout. The concept of the continuity of nature, concept of the continuity of nature has existed in the mind of man, never in the facts of nature. Later in Nature's Destiny, he wrote this: whether one accepts or rejects the design hypotheses, now listen to that language, whether one accepts or rejects the design hypotheses, there is no avoiding the conclusion that the world looks as if it had been tailored for life. It appears to have been designed. All reality appears to be a vast, coherent, teleological whole with life and mankind as its purpose and goal. What does that say? He just got through saying, he calls it a design hypothesis, and then he says, well, boy, it sure looks like there was a designer. Well, by the way, it appears that things have been designed, and in reality, it appears that it's all been designed for the purpose and goal of the life of mankind. How can you say then that evolution is an established fact? Well, we'll have to go back to Joseph Goebbels for that one. Now, I was going to hit one point on the scientific method. Did I miss that? I keep saying 7th grade science. I may have had it. I don't remember when I had this, but everybody remember the whole process? Oh, if you can't do this, then it doesn't make sense. The scientific method is this. This is another kind of decision tree. Ask a question. Do background research. Construct a hypothesis. And what is a hypothesis? It's an educated guess, right? Then test with an experiment. Then analyze results and draw conclusions. If the hypothesis is true, you can report the results. If the hypothesis is false or partially true, what do you got to do? You got to start all over again, right? That is the scientific method that we teach. Well, I don't know where it's taught now. I think it was taught in 7th grade. Of course, I spent 3 years in 7th grade, so I don't know which one it was. But if that process, if that's the scientific method, why don't scientists apply it to evolution? Because it's a faith. It's not a science.
It's more like a religion.
It is. It's exactly like a religion. It is a religion. Okay, let me hit a couple of other pieces here. I was going to quote Kurt one more time. Oh, no, I'm sorry. Already did that one. So now I want to move on to some what are called comparative arguments. And if you're on page 4, that's where we're going to be for a little bit. And we're going to talk about something called the case for homology. Now, let me tell you what homology is first. And I think it's going to be defined here. This is the book I told you that we're kind of adding into the mix. And when we get through with this class, I'll put together a bibliography for you that tells you where you can get all these. And by the way, if you ever wondered if there's anything written on creation versus evolution, there's only like 6 million hits that you can, if you just type it in, you'll find it all over the place. This one is a book called The Case for a Creator. Has anybody ever heard of the case for something that was written by Case for Christ? Lee Strobel wrote this book. The first book he wrote was called A Case for Christ. And that was when he was an atheist, and he set out to prove specifically that there was no such thing as Christ and that there was no such thing as Christianity. He did it primarily because his wife had become a Christian and he just couldn't understand how that occurred. And his process, and this book is done exactly the same way. He goes to the preeminent experts, the scientists and PhDs in the world, and he says, tell me about this. Here's one of the ones that he talks about in terms of homology. Let me see if I think I've got the right one here. Well, first, let me do this. One of the most important arguments for the theory of evolution is provided by evidence from what's called the comparative sciences. Comparative anatomy, comparative physiology, comparative cytology, comparative biochemistry. In other words, it's comparing these from one system to another system to see what's homologous or common among all those systems. When making comparisons of parts of organisms, scientists commonly speak of structures that are homologous structures, which means similar in appearance, as opposed to those that are analogous, which are similar in function. I want you to underline that if you're on page 4. Similar in structure, or similar in appearance versus similar in function. Those are two different things. Now, let me give you, well, let's do the slide first. And we'll see if I... Come on, buddy. There we go. Homologous versus analogous. Common ancestor or common designer? Right? I don't know if you can see what these are, but on the bottom you have, that must be, is that the ulna? You have the human arm. Which one's the ulna? The outside?
Yes.
Yeah, the ulna is the outside bone. Next to that, you have a dog's leg. Next to that, you have a bird's leg. Next to that, you have a whale. At least 3 of those look common. So many evolutionists will say, well, see, look how common these things are. Well, the question is, do they come from a common ancestor or do they come from a common designer? If I'm a designer and I design a tire and that tire works really well, am I going to go design another tire for everything that I do? I'm going to use that same design in everything, right? Well, that's the point, is that homology doesn't really argue for anything other than it appears to be this. Does that mean it came from a common ancestor or it came from a common designer? Let me tell you what Strobel says. I remember as a student seeing a drawing depicting a similar bone structure in a bat's wings, a porpoise's flipper, a horse's leg, and a human's hand. I was told that even though these limbs have been adapted for different uses, their underlying similarity, or homology, is proof that they all share a common ancestor. Dr. Wells had briefly mentioned this phenomenon at the outset of our interview. And here's the question from Lee Strobel, isn't homology good evidence for Darwinism, I asked? Actually, he said, these homologies were described and named by Darwin's predecessors and who were not evolutionists, he replied. Richard Owen, who was the most famous anatomist of Darwin's time, said they pointed toward a common archetype or design, not toward a descent with modification. But I protested. The similarities are there. You can't deny that. Yes, but the explanation can go either way. Design or descent with modification. How do we determine which is true? Similarity alone doesn't tell us. So the argument from homology is not a very good one, because you get back to the question of, did it come from a common ancestor or did it come from a common designer? Now, admittedly, at first glance, descent from a common ancestor appears to be a very logical argument, an idea that seems to make a lot of sense. After all, isn't that how we explain such similarities as brothers and sisters looking more alike than, say, cousins? Well, that's one possibility, but in more recent times, this argument has been carried even to the molecular level as scientists begin to compare similarities in blood groups, cytochrome, C composition, enzymes, cellular DNA, host of other molecules that surround it. It has been announced, for example, that a chimpanzee and humans have DNA that is similar 95% of the time. Well, let me ask you a question. Let's use the tire example again. If you design a tire and the tire works exactly the way you wanted it designed, wouldn't you use that tire on a number of different vehicles? Same thing is true. If you designed DNA and DNA worked, why wouldn't that be common in a number of things in creation? Dale, do you have a question?
Well, 95% of how many? I mean, that makes it sound like it's almost the same. But if there are 25 trillion factors, then 5% difference is a big difference, and that's the case.
That's exactly right. And the other issue is that much of what evolution is based on, and we'll see that here in a minute, has to do with the structure of the body. Doesn't have to do. Over 90% of the body is not structure. What is it? tissue, liquid, things that you can't possibly replicate. In other words, you can't say, you can take a structure, you can take a skeleton, and you can rough out what you think that skeleton looked like, but how can you tell if 90% of the body is soft tissue? All we really have is the structure, right? So, now, what would a creationist response be to this? Well, there's a couple. Unfortunately, I think many of us are afraid of it, and we tend to say, well, I believe it because it's in the Bible and it's faith. Well, that's the wrong way to approach it. Well, first of all, don't argue on their grounds, argue on your grounds, but that's the wrong way to approach it. The right way to approach it is, let's look at the evidence. That's the way to look at it. And first, we have to understand this. The creationist doesn't respond to the argument to deny the similarities. It'd be stupid to say, no, that's not true, 95% is not the right number, it's 44%. Then you're quibbling and it's not going to make any difference. So the differences do exist. The lesson is this. The lesson, rarely is it the facts that are in dispute. Instead, it is the interpretation placed on the facts that are in dispute. So I'll come back to the same point. Is it a common ancestor or is it a common designer? Is my tire going to work on any car? Yeah. So I've designed it to do it that way. Now, the evolutionist argument is successful only if certain portions of the data on homology are presented. Furthermore, consider this. If similarities prove common ancestry, then dissimilarity proves no common ancestry. Do you follow me? If I'm going to say these things are common, shouldn't I be able to take the things that are not common and say these do not prove, or these prove that there is not common ancestry? Is everybody following me? Questions? Okay, everybody still following me. Good. Now, if the dissimilarity is, if you can use the dissimilarity, then you can begin to say, wait just a second, how can you take this as similar but this is dissimilar and say they come from the same ancestor? Only when evolutionists are allowed to pick and choose the similarities that fit evolutionary theory and reject numerous differences can the argument from homology work. Now, let me give you some examples, and they're in your book on page 5. R.L. Wysong, a veterinarian and scientist, gave some data, some lists of such data, among which were the following examples. The octopus eye, the pig heart, the Pekingese dog face, milk of the donkey, and the pronator quadratus muscle of the Japanese salamander, all are very similar to analogous human structures. Do these similarities show evolutionary relationship? If you say a common ancestor, your answer is going to be yes. If you say common designer, your answer is going to be no. He gives another one. The weight of the brain in proportion to body weight is greater in the dwarf monkey of the South American, the marmoset, than in man. Since this proportion is used to show relationship between primates and man, is the marmoset therefore more evolved than man? No. So you understand the problem with homologies and trying to say, and you'll see this, by the way, we're going to see one later tonight, if we get to it. You'll see this used all the time. This bone looks very similar to the bone that a monkey has, or this piece looks very similar to this piece. Therefore, they had to come from a common ancestor. Or did they come from a common designer? Now, the rest of this chapter, there's a section on DNA that I think you'll find interesting, but I don't want to spend a lot of time on it. So I'm going to skip back to something we were going to talk about last week, because I want to finish up on what we a couple of things that we said we were going to review last week, and then also some of the things that we've kept on our list here. Hopefully we'll get to all of them. One is radiometric dating, or Marilyn had brought this up a few weeks ago, carbon-14 dating. How does that work? The other is the fossil record and gaps in the fossil record. We probably won't get to those tonight because they're pretty extensive and I don't want to lose people. I want to go back to what we said last week. We had 3 items we need to discuss. One was, do you remember this? And this came from our session on the Truth Project. Do you remember the concept of irreducible complexity? Now, that sounds a whole lot more difficult than it is. I want you to think about this for just a minute. Let's take it apart. What does irreducible mean?
It's done, it's simple.
It can't be reduced any further than this point, right? Can't be reduced any further than this or it will not function. Here, let me give you an example. Earlier tonight, I went out here and swept off the front porch because got a lot of leaves and stuff happening on it, right? Well, and what I had a broom which had a handle, and I had on the end of the broom, I had straw or whatever they put on the end of brooms now. If I had not had the straw, what would I have been sweeping? Nothing, right? Because all I had was a handle. So the broom is irreducibly complex. It can't get any simpler, can't be reduced any further than the pieces that I had, the broom and the handle. Probably could have got by without the handle, but you get the point. Can't be reduced any further than that. So irreducible simply means can't be reduced any further and function. Complexity is what? Can't be irreducibly, it can't be any less complex than this and still function. Why is that important in the whole discussion of evolution?
Because evolution depends on small minor changes that occur over time.
Bingo. What are the primary requirements for evolution? Very small, very incremental changes over a very long period of time. We're going to find tonight, or maybe next week, that it's at least 560 million years that this has to occur. Now, let's deal with that just a little bit. You can see here, and this is the same example that Dale Tackett used. Tackett or Hackett? Tackett, right? Used, which is a mousetrap. Irreducible complexity is a single system which is composed of several interacting parts that contribute to the basic function, and where the removal of any one of these parts causes the system to effectively stop functioning. If I take the spring out of a mousetrap, how many mice do I catch? If I take the lever that holds it in place out of it, how many mice do I catch? If I take the bait away, why is the mouse even going to go there? That's as complex, or that is, as complex as it can possibly be without getting any less complex and still function. That is irreducible complexity, and you'll see why that is an important thing here when we look at the second concept, which is non-viability of transition forms. Let me read first what Geisler says about irreducible complexity. Let me find it here. We now know that there are many organs, systems, and processes in life that fit a certain description. One of those is the cell. In Darwin's day, the cell was a black box, a mysterious little part of life that no one could see into. Remember, Darwin was 1850-something?
1859 was when he wrote the book.
Yeah. But now that we have the ability to peer into the cell, we see that life at the molecular level is immeasurably more complex than Darwin ever dreamed. In fact, a single cell is irreducibly complex. It cannot get any less complex and still function. An irreducibly complex system is composed of several well-matched interacting parts that contribute to the basic function, wherein the removal of any one of those parts causes the system to effectively cease functioning. Oh, it seems like a big concept, but it really isn't. It's really saying this. You can only take something down to a certain point where it will no longer function the way it should function. That's going to lead us to something called non-viability of transitional forms. Now, that's a mouthful, right? What's non-viability mean?
It
You
don't
didn't
work.
have everything.
Yeah.
It don't work.
Yeah. So non-viability, and what are transitional forms? If we're going to have this very long period of time, we have to have this. Do you remember our Beetle? Well, let me do this slide. I'll come back to it.
The flamethrower?
The flamethrower, right?
Bombardier.
The Bombardier Beetle. Do you remember him?
Yeah.
And he was a cool guy. Let me see if I can find him. Here he is. Remember the Bombardier Beetle? Explain to me how, okay, let's say that we started out with the head and the torso, and that's somehow what we got out of the primordial slime, right? But at this point, we don't have any of the back end. Okay? Well, how about if a bigger Bombardier Beetle decides he's going to eat this guy? This guy can't function without all the other pieces, right? So now we have to wait for millions of years, or some period of indeterminate period of time, for the rest of these pieces to come together before that is a viable transitional form.
How does it survive all those millions of years without it?
That's exactly the point.
He hides.
Yeah. Well, if we take the eyes away, nobody can see him. Well, take everybody else's eyes away, nobody can see him anyhow. So now what does Geisler say about non-viability of transitional forms? Let's see. 148. Sorry. Another problem that plagues the plausibility of natural selection creating new life forms is the fact that transitional forms could not survive. For example, consider the Darwinian assertion that birds evolved gradually from reptiles over long periods of time. This would necessitate a transition from scales to feathers. How could a creature survive that no longer has scales but does not have feathers? Feathers are irreducibly complex. You got to have all the feathers at one point. A creature with the structure of half a feather has no ability to fly. It would be easy prey on land, in water, and in the air. So non-viability means exactly what you said, Dale. They are not going to survive in the survival of the fittest. I've got one more. I want to look at a slide here, but I got one, and then I think we'll stop for tonight. No, we won't. I got one other thing I want to do. Is anybody getting overwhelmed yet?
Oh, just a tad. My brain is hurting.
I'll talk slower.
I don't think that's...
This is a non-viable transition, and you'll see this used, and it's still used. You'll still see this in science books today. This is the Archaeopteryx, and that's his. That's supposed to be his fossil over there. He came from a common ancestor, a dinosaur, and he turned into first the Archaeopteryx and Archaeopteryx. Thanks, Dale. And then ultimately to the modern bird. How did that occur? It's not possible to occur over extremely long periods of time. So let me tell you what. What Lee Strobel said. Actually, Lee Strobel doesn't say this. He's talking again to a PhD scientist, and a double PhD scientist. Earlier in our interview, Wells had brought up another category of evidence for universal ancestry: homology in vertebrate limbs. We talked a little bit about homology earlier. I remember as a student seeing the drawing depicting a similar bone structure in a bat's wing, a porpoise's flipper, a horse's leg, and human's hands. We already talked about that. I was told that even though these limbs have been adapted for future uses, their underlying similarity or homology is proof that they weren't. Isn't homology evidence for Darwinism? That's not the section I wanted, sorry. Oh, here's the section I wanted. This has to do with the, say it again, Dale?
Archaeopteryx.
Archaeopteryx. I've been trying to get that done for days. The question is, do you get from a reptile to a bird, which is an astonishingly huge step, by some totally natural process, or does this require the intervention of a designer? An Archaeopteryx, as beautiful as it is, doesn't show us one way or the other. Besides, we see strange animals around today, like the duck-billed platypus, which nobody considers transitional, which has characteristics of different classes. But the Archaeopteryx is half bird, half reptile, right? This is Lee Strobel asking the doctor, and he says, not even close, he insists. It's a bird with modern feathers, and birds are very different from reptiles in many important ways. Their breeding system, their bone structure, their lungs, their distribution of their weight and muscles, it's a bird, that's clear. Not part of a bird and not part of a reptile. Its transitional form would not have survived. I'm going to hit one more item and then we're going to call it a night. And that is this. And we talked a little bit about this a couple of weeks ago. So how do you account then, how do you get past that point? And this is going to apply to the fossil record as well. Well, Stephen Gould, who we talked about before, came up with a concept in 1972 called punctuated equilibrium. And he came up with it because, on the left-hand side, what do you see?
Gradual change from one species to another.
Which is exactly what Darwin says, right? That's what evolution says, is that these are gradual changes over some period of time. Well, it became very clear that in the fossil record, nobody's finding a transitional form. So Gould said, I got it. It's still over a period of time, but what happens was something in the environment caused this to go all of a sudden. The problem is you still can't find transitional forms of fossils for any of these as well. So punctuated equilibrium, which is a gradualism, is not over. And when he said that's because this is the way it has to be, it's because he said gradualism is non-existent in the fossil record. If gradualism is non-existent, then what does that tell you? The process does not occur. That's why he had to come up with this theory. So everybody's head going, yeah, we'll wait till next week. Greg?
No, we're fine. No, I just, when I read the email you sent, when you go back to, what was that, scientists and religion or however, whatever, I thought it was higher.
Really?
The percentage of
Yeah.
scientists, because in my million years of living and going to college, I was always surprised at how few professors were, what's the nice way to say it, hardcore evolutionists. I'd say 8 out of 10, maybe 9 out of 10, did the design.
Really?
But my impression was, if they got pressured by the other classmates, they would just say, this is a really good design. If you want to believe there was a designer, that's your privilege. If you want to think it was an accident, that's your privilege, because they were all concerned with tenure, their job. Whereas, like when I talked a couple of weeks ago, it seems like most of the famous people were going for sound bites, because that makes them famous, that makes them money. Because I always dealt with professors and places that always said, ooh, similar design, creative design, you know, all this good stuff. And then if you're ever stuck studying genetics, don't do it. But like Dale said, that 5% is huge. You can make a 1% difference between, you know, a horse, pony, whatever you want to compare. That 1% is huge. And most people don't, you know, because genetics just suck, to tell the truth. But if the ever, you know, but everybody wants to argue that little teeny tiny point, like you said, if you just talk in, I don't say generalities, if you don't get bogged down in like, well, that little tiny, you know, what my thing is, how many angels dance on the head of a pin? I don't care. Pick a number. I still don't care.
12.
But everybody gets stuck on these little tiny things that doesn't make any sense.
No.
And then it's a bonus, because of Deborah. Pick on her. I haven't picked on her in a long time. The religion is science fiction. Everybody I know who's heavy evolutionists are so into Star Trek, Star Wars, the wormholes, the warp speeds, all this stuff. I hate theoretical physicists. They're just all psychokillers as far as I'm concerned. They just, you know,
Well-
we know that's out there, but we haven't discovered it, but we know it's a fact. No, it's not.
I personally think, and I don't know how you can get past, and we're going to have to quit for the night. I don't know how you can get further past it than this, and that is that, as I said, everyone believes in something. You believe in evolution because you choose to believe in evolution, because that choice allows you to make decisions that you want to do, as opposed to saying, there's somebody bigger in control of my life. All right. I hope that wasn't too overwhelming. If it was, we'll just do it all again next week. Actually, we do have to finish up a couple things next week that we didn't get to tonight. Radiometric dating and the fossil record. And when we do that, I think you're going to be surprised at, and I will tell you this as well. I'm going to guess this. I can't swear to it. But if you know somebody, if you just go talk to somebody and they say, well, I'm an evolutionist, they are not going to be able to give you 1/10 of the information that we've talked about over the last few months, or last few weeks, however long it's been. They will not be able to tell you why it is they believe in evolution. You know why that is? Same reason. They choose to believe in evolution because they don't want to deal with the consequences of an all-divine creator. All right. Jerry?
Just one quick comment. I visited the Air Force Museum in Dayton, Ohio on my trip, and it's amazing how we're using words. Throughout the museum, they kept talking about how airplanes had evolved. And I thought, no, they didn't evolve. They were done by an intelligent designer.
Yeah. Well, that's true. Remember my tire? Nobody's going to say that Corvette evolved. You know, Corvette evolved from 1965 to 1970, but the basics were all there, right? The only thing they did was change what the designer had designed to begin with, right? All right, let's quit for today. I need to stop recording.